Hey everybody, Mr. Quick here. Today we're going to be looking at Eureka Math / Engage New York Math, Module 4, Lesson 24, True and False Number Sentences, Part 2. It's not actually the title of the lesson, but seeing as how Lesson 23 was also true and false number sentences, this is a natural sequel in the sense that it goes along with what we learned in Lesson 23, and we'll extend it and we'll continue to extend it. So it's a good Part 2 here. Today we're going to identify values for variables in equations and inequalities that result in true or false number sentences. So we're going to have a number sentence that's either an equation, meaning it has an equal sign, or an inequality, right? Less than, or greater than, less than, greater than or equal to, less than or equal to. And we're going to decide what makes them true or false. Let's get started. Okay, we have a chart here, and we've got a few different parts of we've got two different equations, and we have a variable, g. You'll notice that in both equations, they both have the variable g, and so what we're going to do is we're going to substitute these numbers in these equations, and we're going to see if that makes the equation true or false. So let's get started. Here we have 4g, which is 4 times g, equals 32. So if we say 4g, and 4 is 8, that means 4 times 8 equals 32. 4 times 8 is 32, so we end up with 32 equals 32, and that is indeed true. They are equal, right? If we said 4g equals 32 and g equals 4, 4 times 4 is 16, 16 equals 32, and that's not true. That is false. Here we'll go to 2. If we say 4 times 2 is 32, 4 times 2 is 8, it's not 32. So that one is again false. 4 times 0, we know is going to be 0. 0 does not equal 32, so that is false. And 4g, if g was 10, down here, 4 times 10 is 40. 40 does not equal 32, so 40 equals 32 is false. So you may notice, because there's an equal sign, because this is an equation, that there was only one answer that makes that true. 4 times 8 is 32. 32 equals 32. You can't multiply 4 by anything else to equal 32. So there can only be one true answer. Let's go to our next equation over here and see if we can see if that holds up, if there's only one true answer for this inequality. Here we have g is greater than or equal to 8. Greater than or equal to 8. So if I say that 8 is g, 8 is greater than or equal to 8, it's not greater than 8, but it is equal to 8. So that is true. If we said g, we've got 4 is g. If we said 4 is greater than or equal to 8, it's not greater than, it's not equal to, so in that case that would have to be false. 2 is greater than or equal to 8. It's not greater, 2 is not greater than 8, 2 is not equal to 8. That is false. 0 is greater than or equal to 8. 0 is not greater than 8, 0 is not equal to 8. That is false. 10 is greater than or equal to 8. 10 is not equal to 8, but it is greater than 8. So in that case, it's true. So you see that with an inequality, we can look at this and we can determine that there can be, and often is, more than one correct answer. There's more than one correct number that would make the variable, or when substituted for the variable, would make that a true number sentence. Okay, let's go deeper into this. Okay, here we have 6 minus d is greater than 0. So what we want to find is what numbers would make this true and what numbers would make this false. Because depending on what number we put in for d, this statement may be true or false. So I'm going to create a little number line here. We're going to go 0, 1, 2, 3, 4, 5, 6, 7, and we'll start there. So if we look at 6 minus 1, if I take 6 minus 1, I'm going to go back once on the number line, and I have 5. 6 minus 1 is still greater than 0. If I could say 6 minus 2, we're at 4. That's still greater than 0. 6 minus 3 is 3. That's still greater than 0. 6 minus 4, go back another space. That's 2, still greater than 0. 6 minus 1, greater than 0. 6 minus 0 is 6, so that's still greater than 0. Now if I go back, and I was going to go to negative 1. 6 minus negative 1, if you don't know, 6 minus negative 1. When you subtract a negative, that's the same as adding a positive. That equals 7, which is still greater than 0. If we went back to negative 2, 6 minus negative 2, we have a minus and a negative together. That turns into plus a positive. That equals 8, and so on and so forth. So essentially, we know 6 minus anything greater than, 6 minus anything less than 6. So we'll say when D is less than 6, it is true. 6 minus 5 makes it true. 6 minus 4 makes it true. 6 minus anything to the left of 6. Now, if I take 6 minus 6, 6 minus 6, I'm going to change colors here. 6, I'm going to start at 6. We're going to go 1, 2, 3, 4, 5, 6. 6 minus 6 is 0. If I put a 0 here, is 0 greater than 0? No, that's not true. 0 is equal to 0. If I said 6 minus 7, we'll go with orange here. 1, 2, 3, 4, 5, 6, 7. 6 minus 7 is negative 1. That is less than 0, right? It's on the left of 0 on the number line. So 6 minus 7 is negative 1, which is not greater than 0. It's less than 0. So that's not true. If I take 6 minus 8, I would go back another place to negative 2, and so on and so forth. So essentially, this statement is false when D is greater than or equal to 6. And that's kind of what we're looking at today, being able to decide what numbers make it true. So here, this equation, 6 minus D is greater than 0, is true when D is less than 6. When D is 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, anything to the left of 6 on the number line, you could plug it into that equation and you would get, and that would still be an inequality, I should say. That would still be correct. But if you put in 6 or anything bigger than 6, then all of a sudden it's not true. So we would say 6, D is greater than or equal to 6, then it is false. Okay? All right, let's look at another example here. 25 equals D minus 10. 25 equals D minus 10. So what I need to look at here is what minus 10 would be 25? Well, I know that 25 plus 10 is 35, so let's test that one out. 35 minus 10, is that equal? Is it the same as 25? It is, right? And because that is the case, is there any other number I could put in there that would make that true? I can't put 36, because 36 minus 10 doesn't equal 25. I can't put 34. 34 minus 10 doesn't equal 25. So in this case, it is true when D is equal to 35. So if D equals 35, then this statement is true. It is false when D does not equal 35. So basically, when D is any other number, then it is not true. And we show that by showing an equal sign but putting a line through it. That means they are not equal. So if D is 35, it's true. If D is not 35, it's false. Okay, we'll do one more quick example here. 56 is greater than or equal to 2e. meaning 2 times e, whatever number we want to substitute in for the variable e. So 56 is greater than or equal to 2e. So what I'm going to do is I'm going to take 56 and divide that by 2, and I know that my answer is going to be 28. You could solve it and you'd get the same answer. I'm just going to do that for the sake of time. So I know that if e is 28, then these two are going to be equal. So 56 is greater than or equal to 28. But that's because it's greater than or equal to here. I know that 28 can't be my only answer, because if we took 2 times 27, let's say e equaled 27, then you would have 54, and it would still be true that 56 is greater than or equal to 54. It's not equal to, but it is greater than. So I know that this is going to be true. I'm going to say true if, I'm going to rewrite that because that looks terrible. True if e is less than or equal to 28. So if it's 28 or anything less than that, it will still be true, because 28 times 2 is equal to 56, and anything less than that would be less than 56. So 56 is greater than all those numbers. It would be false, though, however, if e was greater than 28. So if we took 2 times 29, that's going to be 58, and 56 is not greater than or equal to 58, right? So anything that is larger than 28 would mean that that statement is not true, so it would be false. Okay, we're going to stop there, and we'll look at some more examples together and talk about this in class. Thanks for watching, and we'll talk to you later.